This unit is called the Multi-Control Display Unit, MCDU, because it has the capability of accessing 4 different systems. They are the FMGS, ACARS, AIDS, Integrated Data Systems, CFDS, Central Flight Data System. The last 2 items are for maintenance use. There are 2 MCDUs, one on each side at the front of the pedestal. MCDU-1 inputs data into FMGC-1 and MCDU-2 into FMGC-2. The brightness knob increases the lighting in the entire display. Although the lights cannot be turned off, in this position they are dimmed. Full clockwise will turn them to bright. Should an FMGC fail, an amber fail light illuminates on the FMGC. If you are accessing another system through the MCDU, such as ACARS, and the FMGC needs your attention, a white light illuminates. During flight, should a system other than the FMGC request your attention, the MCDU menu light will illuminate. The MCDU is basically divided into 2 parts. First is the upper part, which contains the display and some keys oriented to specific lines on the display, called line select keys. 6 line select keys, generally abbreviated as LSKs, are located on either side of the screen. These keys are numbered 1 to 6 from the top to the bottom. For example, the LSK used to access the FMGC is called LSK1L, where L stands for left. Then there is the lower part, which contains a numeric keypad, a letter keyboard, specific page keys, and some function keys. Let's look at the page layout. A page can display 14 lines of text. There is 1 title line, here labeled Approach. 6 label lines, 1 for each data line, the examples being QNH, Temperature, Magnetic Wind, Transition Altitude, V Approach, and Previous. Then there are 6 data lines, which correspond to the line select keys. For example, the altimeter setting of 29.95. At the bottom of the screen is the scratch pad. Information to be entered into the FMGC is first written in the scratch pad using the alphanumeric keys. The outline keys are page select keys. Each key calls up a page with information specific to that regime of flight. For instance, the F-PLN key calls up a page which is used either to build a flight plan or to check a company route. The PERF page, for performance, is used to enter V speeds, climb, cruise, and descent speeds. The MCDU is organized in terms of phase of flight. For instance, when the aircraft is first powered up, the FMGC status page is automatically displayed. Should the performance key be selected during climb, the climb page will automatically appear. Or if the aircraft is descending, selecting the performance key will bring up the descent page. The flight management system uses 2 databases to perform its computations, a navigation database and a performance database. The navigation database contains all the necessary information for the lateral flight plan, such as routes, airways, BORs, NDBs, waypoints, and airports. The navigation database is updated every 28 days, and its currency and validity is checked on this page during the pre-flight. Notice there is an active database and a secondary or second database. The second database is either the previous or the next database. Databases are loaded 2 at a time, so that if the first one expires away from a maintenance base, the pilot can activate the second one before departure the next day. The performance database contains the aircraft performance model and is used to optimize the flight plan and to obtain predictions such as ETAs, fuel burn, and step climbs. The performance factor is used to modify the aircraft performance model for the individual aircraft. The value 0.0 in percentage units is in blue, indicating that it can be modified. The A320 family is equipped with standby instruments, which include a standby airspeed indicator, a standby altimeter, a standby horizon, a standby compass is installed on top of the windshield center post in a closed compartment. It may be pulled down for use. A deviation card is installed above the compass. The standby airspeed indicator is equipped with movable airspeed bugs. The standby altimeter has an altitude pointer, an altitude counter, a baro set counter which displays pressure setting in inches of mercury or in hectopascals, depending on the option chosen, a baro set knob. The standby horizon is erected by pulling the caging knob. This is the only standby instrument requiring an electrical supply. In the event of total electrical failure, it continues working for approximately 5 minutes. In case of instrument or power supply failure, a failure flag appears.